Assalamualaikum and good evening. Alright, my name is Muhammad Muiz and my partner is Firdaus. Today we will explain about our lab session, which is voltage regulator. This is our circuit. In this lab session, we need to design a circuit, which is a simple regulation voltage. For this circuit, this is a series voltage regulation. Why is this series? Because the regulator series with the load. Alright. So from our transformer, you can see that the signal of AC signal, because this our source we use the AC signal. So from this AC signal we want to change the AC signal to DC signal. So we put rectifier to change the AC signal to DC signal. But in rectifier it's not smooth as a DC signal. In rectifier process, all the negative wave from the signal become positive, but the signal is not smooth as a DC. So we take the filter, we put the filter. Our filter is capacitor. From this wave or from this signal, it become like this, but not smooth as a DC, but in one line compared to this one. So the purpose of the regulator is to make this signal more smooth and more like a DC signal. So this is the final result. The signal become a DC signal. From the left sheet, we need to choose many options for the voltage input. So we choose for the voltage input is 10. In this circuit, we got the voltage input is equal to 8.9, which is 9. We can call it 9 and almost to the 10. But for the output, we decide to take 2.5, which is our diode is 3.3 to calculate or to measure the output. The VZ or voltage from the Zener diode need to subtract or minus with the VBE, which is 0.7. So our Zener diode value is 3.3 and our VBE is 0.7. So we got the output from the calculation is 2.6 and from the simulation we got 2.5. Alright, for this circuit, for the shunt circuit or second our second circuit, which is our V input is equal to 9. So from the simulation, from this circuit we got the voltage input is equal to 8.8, almost 9, and the voltage output is equal to 3.713 volt. From the previous circuit, we used the series voltage regulation, but in this circuit we use shunt voltage regulation. What the difference between shunt and series regulator? In series regulator, the load is series with the regulator, but in shunt, the load is parallel with the regulator. So from the wave, from the transformer wave, we can see this signal for the AC signal, which is have a negative and positive wave. So to make it to DC, we use rectifier to make sure all the negative signal become positive like this. And we use filter to make it more smooth like this. The wave in this result or in this oscilloscope become one line, become one line and become more smooth. And for the regulator voltage, and it's become more smooth and become a DC signal.
Okay, next we go to the improved series voltage regulator using op-amp. Okay, for the input we use 240 VRMS and the frequency is 60 Hz. For the winding we use 20 to 1 for the transformers. Then we use the rectifier. We use the 1B4 P42. For the capacitor we use 10 microfarad. The resistor we used for R1 is 10 kilo ohm and the R2 is 100. The Xeno diode we use is 1N4728A because the value voltage here is 3.3 volt. Okay, now we use product OM. We connected the OM, the positive one to the diode and the negative one to the voltage divider right here. Okay, for the VCC we use 12 volt. For the VEE minus 12 volt. For the transistor we use BD135 is a step like a state in the lab sheet. Okay, now we want to run it. For input we got 9.993 volt is close to 10 volt. We chosen the 10 volt. Okay, for the output we get 5.702 volt. Okay, now let's look the waveform. The first one we got is the red one is the voltage from the power supply, and then the green one is after the step down voltage. Okay, next second one, this has ripple voltage. The third one is the filter after the filtering process. We got like this, almost the straight one, ripple. Okay, for the last one, we get the straight line, smooth straight line right here. For the scale, if you use the same scale, even the same, just the output. Okay. Okay, now let's look to the improve shunt voltage regulator by using op-amp. For the input, we use the same input, 240 VRMS. The frequency is 60 Hz. The winding, which is with 24 to 1 for the transformers. Okay, for the rectifier, we use 1B4 P42, and the capacitor is 10 volt, 10 microfarad. And the resistor for R1 we use 3 kilo ohm, and for R2 is 220 ohm. For the RS we use 1.2 kilo ohm, and the op-amp we connected the Xeno diode. The diode we use the same one, we 1N4728A. Okay, now let's run the circuit. Okay, for the input we use the voltage 9.002 volt. These are slightly different from we chosen the 9 volt. Okay, for the output we get 9.186 millivolt. Okay, now let's look to the voltage waveform. Okay, this is the waveform we get. Okay, the green one is the step down. After the step down, then the second one is a voltage ripple, and after the filtering process we get this one. The line, the voltage ripple is smaller and smaller, and then for the output we get the result, the purple one. The purple one is the very smooth line. For the yellow line is still the ripple a little bit, and the result we get the smooth line. Okay, thank you.